Limit as z goes to 3 of z cubed plus 2z squared minus 9z minus 18 over z squared plus 2z minus 15. The first thing we're going to do is try plugging in a 3 for each of the z's. In the numerator we will have 3 cubed plus 2 times 3 squared minus 9 times 3 minus 18. In the denominator we will have 3 squared plus 2 times 3 minus 15. In the numerator, 3 cubed is a 27. 2 times 3 squared is an 18. Negative 9 times 3 is a negative 27, and then minus 18. In the denominator, 3 squared is a 9. 2 times 3 is a 6, minus 15. In the numerator, the 27's cancel and the 18's cancel. We have a 0 in the numerator. In the denominator, 9 plus 6 is 15, minus 15 is a 0 in the denominator. We have the 0 over 0 indeterminate form, and we need to rework this to determine it. Since these are power functions, we're going to try the factor and cancel method. Limit as z goes to 3 of. Now in the numerator, this is a 4-term cubic. It has all of the terms represented, z cubed, z squared, z, and a constant. One way to attempt to factor this will be the group factor method, where you group together two pairs of terms. I'm going to group together the z cubed and the 2z squared, and then the negative 9z and negative 18. Notice I'm putting parentheses around them and putting a plus sign between them. The denominator is just a standard trinomial factorization of z. We will wait to factor that once we factor the numerator. So we have limit as z goes to 3 of. Now, we want to remove common factors out of these paired groups here. The first pair has a z squared common factor, and that'll have a z squared times a z plus 2 result. The second pair has a negative 9 factor, which will leave a z plus a 2. There's where you can see whether or not the group factoring method works. It does not always work, but it works as long as these match each other. They're both z plus 2, and therefore the group factor method works. I haven't yet factored it completely in the numerator, so therefore I'm going to save the factorization of the denominator so that I have the factorizations happen in the same step. So we have limit as z goes to 3 of. In the numerator, we can factor out a z plus 2, and that will leave us with a z squared minus 9. In the denominator, trinomial factorization with z, we need two numbers that multiply to be negative 15 and add to be a positive 2. It sounds like a positive 5 and a negative 3 will take care of that for us. Now this is still 0 over 0. We haven't canceled the factors that are making the zeros in the numerator and denominator, and we still can't do that just yet since we don't see them both. Since z is going to 3, we would expect to see a z minus 3 in the numerator and denominator. We do see the one in the denominator, but we don't quite see the one in the numerator just yet, but there is a difference of squares up there that will factor a little further. The numerator will be z plus 2 times z plus 3 times z minus 3 for that difference of squares, over z plus 5 times z minus 3. And we can finally see the two factors that are making the 0 over 0. We can now cancel those out, and we should no longer have the 0 over 0 indeterminate form occurring. So we have z plus 2 times z plus 3 over z plus 5. We can now try plugging the z's in, and we end up with a 3 plus 2 times a 3 plus 3 over a 3 plus 5. In the numerator, 3 plus 2 is 5. 3 plus 3 is 6. In the denominator, 3 plus 5 is an 8. In the numerator, 5 times 6 is 30 over 8. These have a common divisor of a 2. We'll reduce it by 2 to become 15 over 4.